Okay, vocabulary review. Is the x-axis vertical or horizontal? This is lesson 8, unit 5, second semester, 7th grade math. Is the x-axis, is that vertical or horizontal? Who's got the answer? Unisa. Yes, that's a horizontal axis. Now, before I reveal these answers, can somebody tell me what do we name the 7th point here? What's the name of that point? Who haven't I called on yet? Karis, what's this point called? This is called the origin. Very good. And it intersects. It's the point where what two axes intersects? The y and the x. Okay, now, next question. Number 2, which axis does this point lie upon? Think about it. Which axis does this lie upon?
The x-axis.
The x-axis. How about this one over here?
Y.
Very good, the y-axis. So I feel like you guys are pretty good on graphing. Let me reveal the answers to you. And I heard some people say this is easy. Yes, this is easy. This is review. We've gone over this so many times. But here's why we're going over this now. We're going to talk about scatter plots. We're going to interpret scatter plots. And what I want you guys to connect is this information with what I shared with you on slope, positive slope, and a negative slope. Remember what those lines look like? A line that has a positive slope and a line that has a negative slope? Which way it leans? That has to do with what we're about to talk about. So what you'll learn, to draw and interpret scatter plots, new vocabulary, scatter plots. Now here's the thing. Positive slope, think about that word, because this new vocabulary word, positive trend, they go together. Negative trend goes with negative slope, think about that. And then no trend means not no slope, it's like there's no relation. You'll see what I'm talking about in a moment. Now why learn this? You can graph data, such as the data shown below, as points in the coordinate plane. The graph may show an important pattern. So if you look, x and y's, these are coordinates. A scatter plot is a graph that relates two sets of data. To make a scatter plot, graph the two sets of data as ordered pairs. So here I go ahead and make the scatter plot here. Now I want to bring something up here. If you look, no, we're not going to connect the dots. What we are going to do is, if you notice, look at my graph. It's book bag weights, the weight of your book bag. And if you notice, on the x-axis, that's how many books are in your backpack. And if you look, the y-axis, that's how heavy your backpack is. And what you might notice is, doesn't it make sense, but you can see it in the graph, as you have more books in your backpack, isn't the weight of your backpack going to tend to increase? Okay, so what we have here is a best fitted line would have a positive slope, and this would be a positive trend. Okay, so I'm trying to connect some things we learned earlier. So a little bit of review. We're going to graph this data in the scatter plot. I wanted to go ahead and graph this with you because I feel like some of you guys are a little rusty on this, so I'm going to go and do this. I took all of these points from the sideways t-chart, and I made my coordinates here. Do you guys see that? So the first one, 58 and 57 and 5/10. And then look at the last one. I did that all the way to the last one, 69 for my x-coordinate and 70 for my y-coordinate. So these are all these coordinates from the t-chart. So I'm going to go ahead and graph these. And so this is arm span to height, okay? And so there is a relationship between the two. So if you look, the first coordinate, 58. So these are on my x-axis, it's counting by units of 2. And this would be 58. And then that would be about 57. Okay, next one, 64, 62, 64, and some change. And I need to be at 64. So this is 65, so 64 would be somewhere right about there. 67. Well, this is 68, so 67 is just shy of that. And then 68 and a half is just going to be shy of 70. Okay, 65 and a half. Well, here's 66, so just shy of 66. And then we're going to go here. This is 65. I'd say that's about 66. Continue on.
I have a question.
What's your question?
Why does the board look
Because we have a line break that I put in there. Remember that from the last lesson? So here we got 60, and then I got 62, and that's going to be 63-ish, and I need to be at 62 and a half. So, okay. Question? Yes. You can use it here also, and I'm going to show you why. Because I'm only showing you, I didn't have to use it, you're right. I could have just drawn my line here. But I just wanted you guys to see that, hey, we do have 0 somewhere down there. All right, so let me go ahead and graph this. 69 would be right about here, and here is 70. 62 and some change, and then we're at 63. Okay, 64 and 66, here's 64. 66. 71 and 72. All right, so if you look at this, if I was to draw a line, a best fitted line through this cloud of points, do we have a positive or negative trend? Positive slope, negative slope for that line. Positive slope, so that's a positive trend for that scatter plot. So take a look. Here we have the scatter plot in the first example shows a relationship or trend. As the number of books increase, the weight of the bag generally increases. Same with your height and your span, right? The span from your fingertips to the other fingertips, right? There's a relationship between that and your height. Now, you can examine a scatter plot to see what kind of trend is shown. This is a positive trend. This is a negative trend. This is no trend. Okay? Now, listen to me. Positive trend leans to the right. Negative trend leans to the left. Positive trend, increase. As you increase to the right, positive direction, you go up positive. Negative trend, one's positive, one's negative. Okay? Describe the trend in the scatter plot. What's going on here? You're saying no trend? Positive trend. Now, using words and the label of the axes and the title of the scatter plot. As the age of the tree increases, the diameter of the tree increases. So this is the label for the two axes. Positive trend. Now, this is what I was talking about earlier. The slope of the best fitted line would be what? Positive. Be ready for that on your quiz tomorrow. What's your question?
Is there a way to evaluate if it's going to be positive or negative or just no slope?
There is a formula for that line that I drew called the best fitted line. Please stop. You're going to learn it eventually. There's a way to calculate the slope of that line. Okay, it's called the best fitted line. They're not telling you that now, but I'm telling you that for later so you can make the connection.
If you can't see whether it's...
There's a way to calculate it so you can actually calculate the slope of the line and the equation for the line. Okay? But that's not what you're expected to do yet. We're just trying to put all the pieces together, like the foundation, before we get there. Okay? Yes? Question? That's the line that goes through the points in the scatter plot. And the best fitted is the one that would be best fitted to go through as many of those points as possible. Okay? So I just eyeballed it. I didn't actually calculate it. I just estimated it. But there's a way to calculate that. Okay? Now I want to get through this last part. How does a scatter plot relate to sets of data? We're almost done. How does it relate to the... It lets us know if we have either a positive, quiet please, It lets us know if we have a positive or negative trend. I feel like that's a better answer than what the book says. It lets you know what happens when one of the data sets increase. Okay? Do they both increase, or does one increase and one decrease? Remember, if they both increase, positive trend. If one is increasing while the other is decreasing, that's a negative trend. Okay, and then you obviously talked about no trend. Now take a look at this scatter plot, because this is where we see, these are the type of questions you're going to see here. Now, here's my scatter plot. I'm going to go ahead and draw a best fitted line. Okay, and we can see is this a positive or negative or no positive, right? So, this is a type of question you'll see tomorrow. If you take a look at this coordinate 25, 8, I need you to look at the title of the axes and the scatter plot and tell me what those numbers represent, please. 25 and 8, they represent something. What does it represent? Leah? Sorry. Laura. What do they represent?
Like number themselves?
Yeah.
25 is X and 8 is Y.
Okay, you're close, but I need you to look at the titles to explain that in more detail. Trinity.
25 is the age and 8 is
Very good. So 25 is the age of the tree. 8 is the diameter of the tree. Okay, now, if we took a look at this, a tree that is 40 years old has a diameter of 9 inches. Is that data point represented in this scatter plot?
Yes.
40 years, 9 inches. So at 40, this would be, is that in my plot?
Yes.
Yes. So the answer is yes. Okay, now, this is where I start to lose a few students, but it's not difficult. I need you to estimate using the data. If a tree is 28 years old, how wide is the trunk? What's the diameter going to be? Using the data, if it's 28 years old, how wide is the trunk of the tree going to be? So first, you find 28. Here's 28 about, right? And 28 intersects right about here, which would be what? 7. About 7. Take a look. About 7, between 6 and 8. Shh. Now, this is where some people drop off. They get stuck because it's a little different. Now, you don't want to figure out the age of the tree by cutting it down. You can figure out by measuring the diameter and using this chart. So, what would the age of the tree be with a diameter of 10 inches? Here's 10, going across. What do you think that is about?